Okay, I'm probably going to do a couple questions together at a time here, but this is the second part of the test, Unit 6, Graphing Polynomials, and we're in the part where you can use a graphing calculator. And all we had to do was, it says, given the function, use direct substitution to evaluate f of negative 1. You've got the function on your paper, f of negative 1. It was negative 3x to the 4th, so I'm going to put negative 1 all to the 4th. This is important to use parentheses. Minus 2x squared, so negative 1 squared, plus x to the 5th. Okay, so it's negative 1 to the all to the 5th minus 2. So you solve this thing out, and this is just 1. This is just 1. This is negative 1. So you get negative 3 minus 2 minus 1 minus 2, and that's negative 8. And that's f of negative 1. Pretty hard was that one right there. Okay, number 2. It said, given the function is 2x to the 4th, so we should write that down. I'll pause it and I'll write it down really. So it's 2x to the 4th minus 2x cubed minus 2x squared plus 20. And you notice I purposely left a gap there. And if you got it wrong, it's because you did not notice the gap when you counted the powers and put them in order. There is a plus 0x in there. And that's probably what messed you up and why you're doing this video for this part. So when I do that, I'm going to have to do, it says use synthetic substitution, which is another way of saying synthetic division. So we're going to go like this, 2, negative 2, negative 2, 0, 20. Do it in there. And I'm supposed to use it for f of 3. F of 3 is what they want. So the remainder here is the answer. That's the answer right there. Once I know the remainder right here. So this is telling me use x equals 3. So that's what I'm going to put right there. There's x equals 3. So let's go through it here. So that's a 2. 2 times 3 is 6. And that's going to be 4. 3 times 4 is 12. 12 and negative 2 is 10. 3 times 10 is, so this is where the mess up is. If you don't have the 0 there, it changes everything. 3 times 10 is 30. So you get a 30 here. 3 times 30 is 90. And so when you add those two, you get 110. There's our answer, 110. Okay, so number 3 was suppose x minus k, just reading it, x minus k is a factor. Well, remember the remainder, that means the remainder equals 0. What do you know about f of k? Well, we know that we're going to say x equals k. So f of k means you're taking the x value, putting it in here, and if it's a remainder, we know by the remainder theorem, when you evaluate the function, it tells you the remainder. So the remainder is 0. Pretty interesting. So if this is a factor, then you know that when you input k into the function, you get an output of 0 because it's a factor. It gives you a remainder of 0. Let's look at number 4. Okay, so we look at number 4 here, and I've sketched the graph here. The ends are different, so A is not right. A is not right because it has opposite directions, which means the degree is odd. Okay? B. Now I don't really read these the same way they do. I always read the x part first. So that as x goes to infinity, y goes to negative infinity. Well, that's not what it does. It actually goes the other way, so that's wrong. So it should, if you were doing that right, it should be as f of x approaches positive infinity, then x approaches infinity as well, positive infinity as well. That's what it should be. So that one was not right. Part C has a similar kind of thing. I'll do it in a different color. It says, as x approaches negative infinity, y approaches positive infinity. Well, that's not right. It should be f of x approaches negative infinity as x approaches negative infinity. So that was wrong. Part D said the leading coefficient is negative. If the leading coefficient were negative, then it would look like this. Since it's a degree that's odd, whoops, it would look like this. So what the function would look like on the graph. If degree is odd and has a negative leading coefficient. Okay? That's what it should look like. So the only option, probably the last option, is the leading coefficient is positive. And that's the correct one. Okay. One more question in this section, number 5. We clear the background here. Okay, number 5. It says, okay, so we're given the function f of x equals a x to the nth power. What must be true about a and n if, okay, again I read these backwards. As x, so here's the coordinate here, as x gets bigger, I'm reading it backwards, y gets smaller. Okay, so that means we're going like this is our end behavior. Then it also says as x gets smaller, f of x also gets smaller. That means we must be coming from here. That's the shape of our graph. It looks something like that. It might be just like a parabola, or it might go like this a bunch of times, but it's got to be something with that kind of end behavior. That only happens with the same direction end behavior when the degree is even. Same direction end behavior. Okay? Now, if it was y equals x squared or x to the 4th, then it would go something like this. Something like that. But the fact that it's upside down means it must be negative, some kind of negative in here to turn it like that. So that means the degree is even, but a, which is a leading coefficient, must be less than 0 or negative. Okay, we are done section 5-2.